All right, welcome back everybody. Today we're going to start up Chapter 7 talking about Java array lists. Now Chapter 6 was all about arrays, Java arrays. Okay, here we're talking about something different called array lists. Okay, both arrays and array lists are used to store information. Okay, they're essentially both lists. Okay, but an array list is going to be a different, kind of more complicated type of object compared to an array with some different advantages and disadvantages over it. Okay, so still talking about data structures, but we're talking about a slightly more complicated data structure in this chapter. Right, so now before we talk about array lists, let's talk about why we need them. Basically, let's talk about what's wrong with Java arrays. Now, a Java array is the simplest data structure available to us in Java. Okay, it's really what most of the other data structures are built off of. They're simple. In a lot of cases, simple is good. That means that they're fast as far as computing time goes. Also, that means that they are efficient with storage. Okay, they don't take up a lot of memory. But there's a lot of basic things that an array can't do that the array list is going to solve. For example, if I want to print the contents of a Java array, I don't have an easy way to do that. I actually have to write a loop and manually print off each part of it. Okay, or the big thing is if I want to resize a Java array, there isn't a good way to do that. I actually have to write a method that will create a loop that goes through the original array and then makes it one bigger and puts that next element in the right spot. Okay, that's the big thing that our array lists are going to fix, is they'll be more flexible, they'll be resizable. And those will be two of our biggest characteristics of an array list. I'm going to say an array list is a complex data structure that houses an array. Okay, so it's a data structure that kind of wraps around an array with some extra functionality. And the two big things about it is it automatically resizes when elements are added or removed. And then also it automatically prints the elements when I go to print that array. Now the first thing I need to know about arrays before I can use them is that they require an import statement. We'd say the array list is not part of the built-in Java language package, so you must let the compiler know that you plan to use them. Okay, just like our scanner class is not part of the built-in package, we have to import it before we're able to use our scanner. Well, same thing with array lists. Okay, why does Java do that? Well, if it only gives you access to the specific stuff you need, okay, the basic language and then the specific classes you import, okay, that's going to make your programs you write quicker to use, more streamlined, take up less information. Okay, to do that, I'll use this statement here, import java.util.arraylist. And then the nice thing is you never have to memorize import statements. There's no import statements on the AP exam. So once we've imported the ArrayList class, we can start using it. Okay, we'll say that an ArrayList is an object of the ArrayList class, and you need to use the keyword new and the ArrayList constructor to use ArrayLists. Okay, what I have here are two different ways of creating an ArrayList, and as you can see, neither of them fit in this slide here, so kind of a long line of code for it. Let's walk you through that. I will tell Java that I want an array list, and then we have these pointy braces for the type of object I'm going to put in that array list. Okay, just like if I wanted a string array, I'd tell Java I want an array of strings here. Well, same thing, we need to tell Java what type of object we want to put into that array list. We'll give it a name, and then we'll use the new constructor. We'll say equals new array list. Once again, we'll say what the class name is that we're creating the list of, and then the parentheses here, the open parameter list. Okay, or we can do the same thing, array list, class name of the array list equals just new array list without these pointy braces in the class name. Either one of these will work. We're not really going to see the difference in this course, but let's say you use this first option. There's a few more things the compiler will catch if you do it this way as opposed to the second way. So let's say we're going to make array lists like this. All right, and when I call that code, so let's say I want to make an array list of strings called S. I can simply declare it just like with any object. Okay, and by running this code, we will have a spot in Java's memory to hold an address for an array list. And we'd say at this point it's null, it doesn't point to anything. Okay, or I can assign it, which would actually create the array list and point that reference variable to it. Okay, we can say that S is a reference to an array list. Okay, so array lists work like all our other objects in Java. Now, the next thing you need to know about array lists is that array lists can only store objects. They can't directly store our primitives, such as ints, doubles, or booleans. Okay, the reasons for this, we'll get into it at the end of the course when we start talking about hierarchies of classes and inheritance and polymorphism and stuff like that. But for now, what you need to know is that if you want to store a primitive value, such as an int, double, or boolean, you must use one of the wrapper classes so that that primitive value is treated like an object. All right, so what is a wrapper class? Okay, I'm going to say that for each primitive type, there's a corresponding wrapper class. So for example, our int primitives have a corresponding integer object. Same thing with our double primitive, has a double object with a capital D. Our Boolean primitive has a Boolean object. And this will be the same for our other types of primitive values like our floats, our longs, and all the stuff we don't really worry about. I would say the wrapper classes wrap the primitive into an object. If you think about some of the example classes we use that basically just store a single int value or double value or something like that, we have some methods attached to them. That's basically what our wrapper classes are. They store a single value of a specific type, but then have a little bit of additional functionality to make them easier to work with. So for example, the integer class wraps a primitive int into an integer object. And there's a couple of ways I can create one, but kind of the most straightforward way would be, I'd say I make an integer object I and set it equal to a new integer, let's say 77. And what this will do is rather than storing an int as a primitive, is it's going to store I as a reference to an integer object where that's storing a 77 here. A couple of methods, the things that you will need to know for the AP exam coming along with that is the .int value, which just returns the value of the integer as an int. Okay, so that'd be taking just the int out of the object and returning it. And then also what we'll see show up, and we'll make sure we throw some examples at you with this, is some constant values, the integer class dot min value, which is the minimum value represented by an int in Java. And then also integer dot max value, which is the maximum value represented by int in Java. Okay, this class contains a reference to that and is probably the easiest way to get those max and min values. Okay, we also have the double class, which wraps a primitive double as an object. Okay, so same idea, double D equals new double 3.14. Okay, which is going to create a double object reference that points to the double object with that double value stored. Okay, again, there's some methods and some kind of qualities of that class that we won't necessarily use. I suppose the one thing we might use the double value, which returns its value actually. And we can go through all our other different primitive types like booleans, floats, longs, and take a look at how the wrapper class wraps up that primitive type, okay, into an object. And each of those classes are going to have some various kind of functionality to them that we don't get with just the primitive. Okay, we're not going to spend a lot of time with that just because of something called auto boxing and unboxing. We're going to say that Java now, okay, so as in 10 years ago when folks were taking this class, didn't do it then, but Java now wraps and unwraps automatically. Okay, meaning that when it comes time to make these wrapper objects, a lot of the work's going to be taken care of for us as far as wrapping and unwrapping, and we're really not going to have to think too hard about taking it into an actual object integer or double to the object double. We'll show you what we mean by that here. So first thing we'll talk about is auto boxing. That's going to be the automatic conversion that Java makes between primitive types and their corresponding object wrapper classes. Okay, so we tell Java that a part of a program is going to use an integer object. We pass in an int primitive, Java is going to automatically box up that int into an integer object. Okay, so they say the Java compiler applies auto boxing when a primitive value is first either passed in as a parameter to a method that expects an object of the wrapper class. So again, if a method expects an integer object, we pass in an int primitive, Java is going to automatically box that up as the object. And then also it'll auto box when it's assigned to a variable of the corresponding wrapper class. And I'll show you what that looks like in a second here. So as an auto boxing example, I have two lines of code that essentially do the same thing. I can say I want to make an integer object called num, call the new constructor, integer constructor, and pass a int parameter in. Okay, or I can just say integer num gets 13. Java will auto box that primitive 13 as an integer with the two statements being equivalent. Okay, so once again, a lot of the hard work's getting taken care of for us behind the scenes. We really don't need to think too much about the int as an object. Java kind of boxes that up for us. All right, unboxing then is the automatic conversion that Java makes from the wrapper class to the primitive. So as in we have our object, we want to treat it like a primitive. In most cases, Java is going to take care of that conversion for us. We'll say the Java compiler applies unboxing when a wrapper object is passed as a parameter to a method that expects a value of the corresponding primitive type. So if we have a method that expects a primitive, let's say int, but we pass in an integer, Java is going to unbox that value for us. Okay, also when it's assigned to a value of the corresponding primitive type, okay, same idea. If I go to assign an int to the object of that same wrapper class, okay, it's automatically going to unbox it for us. Okay, so unboxing examples. Let's say I make a double object called num and I create it with a new double constructor. Now again, I could just pass in a double primitive and that would auto box it for me. Okay, but let's take a look at these next two lines of code. I could say double D equals num get double value. Okay, so actually calling the double value method, all right, on that num object, that would assign D to this 1.1. Okay, so that's, using that object's classes. Or I could use my auto unboxing by just saying double D gets num. Java will automatically unbox this number object, get the value, and assign it to D here. Okay, either of these last two lines of code will work. They'll give me the same thing, the same value stored as that primitive D. Okay, so again, that's the idea of auto boxing and unboxing. We are technically, when we're working with array lists, always working with objects, but because of auto boxing and unboxing, we really don't need to think about them as objects. Java takes care of a lot of that work behind the scenes for us. So once we've created an array list, we can start using its methods. And like we said, the big advantage that an array list is going to have over a simple Java array is going to be its functionality, the methods available to us. Okay, here's a quick list of those methods, and what we'll do next is run through each of them and how they work. So first thing, once an array list is created, is that array lists always start out empty. Okay, there isn't a way to assign an array list with default values. Okay, you must use the add method to add elements to the array list. And then as we do that, as we start adding elements to our list, okay, the other thing to know is that array lists are resizable, as in an array list will automatically be resized when you add or remove elements. All right, so first up, let's talk about the add method. So my first two lines of code are going to create the array. And I have those on two different lines just because I can't fit it all in one line here on my slide. Okay, so we're going to make an array list of integer objects called nums. And we'll instantiate that by saying nums equals new array list of integer objects. Okay, running those first two lines of code is going to give me an empty array list ready to hold integer objects. And when I call this next line of code, nums.add34, essentially what that's going to do is put a 34 into my array list. Okay, when I call my add method again, it's going to add that value to the end of my array list. I'm just going to leave some space here so I can keep filling things in. Okay, so that's my add method. And like we said, with autoboxing, I can pass in just simple primitives. I don't need to construct a new integer object. We can just pass in the ints and they get boxed up as integers for us. Now the add method is also overloaded, as in I have a single parameter add method which is going to add to the end of the list. But then I also have this two parameter where the first parameter is my index and the second parameter is what I want to add. So when I call this method, it's going to say add at index 1 a 7. Well, as far as indexes go, we have 0, 1, 2, 3, 4. So we're going to add the 7 here. And what that's going to result with is the 34 will now have a 7 at index 1. And that's going to shift anything else above that up an index. Okay, same idea when I call this nums.add at index 2 a 3. We'll keep everything before that index the same. And then at index 2, we're going to add the 3. And then that would shift everything else up one index. Then if I call my first add method one more time, the single parameter with the 11, that's just going to add the 11 to the end of my array list. Okay, another advantage of array lists, again, is we can just print them off. If I go system.out.print nums, it's going to give me the representation of that list, okay, just printing off all the values to it. All right, so next thing I want to talk about is the set method. And the big thing we'll do here is make sure we're not confusing the set method with the add method. So let's say we say array list string strs. That's going to create a space for a new array list called strs that holds strings. And then strs gets new array list of strings, so we've instantiated it. And after the line 2 of code, we have an empty array list ready to hold string objects. And then our next 3 lines we're just going to call the add method, adding 3 different strings to that list. So after our next 3 lines of code, what we'd have is an array list with these strings AP, the string CS, whoops, dyslexia there, and the string Java. Okay, so just like we had in our last example. And then the next thing I have is the set method. So we have strs.set1CSA. What the set method does is it takes first parameter as an index, so it tells us where we're setting something, and then what we want to set it to. And what this is going to do is, unlike the add method, is just going to reassign what's at that index. So my result after this line of code would we still have the AP in index 0. Index 1 is now going to be CSA. And then index 2 would still be the Java. All right, and that's really the difference between our set method and our add method. The set method resets what's there and doesn't do any shifting, doesn't do any expanding of the array. It just cancels out what is there and replaces what we set it equal to. When I print my array now, yep, we have the AP, the CSA, the Java. So that's how our set method works. All right, let's take a look at one more detail with my set method. Okay, I'm going to create the same array strs. I'm going to add the same original 3 elements to it. And now this time I'm going to print off what's returned by my set method. Okay, so the question is, what is this going to give me? Well, when I run this code, it's going to do this, have the same effect on my array. So we'll just print that off here quick, or we'll just write that down here quick. So this code here is going to give me an array of strings with AP, CS, and Java. And when I call this set method here, once again, what it's going to do is it's going to replace what's at that index 1 with the CSA here, okay, with what we want to replace it with. And then my question is, what is this going to print out here when I go to print the result of my set method? Well, that's going to be a CS. Okay, my set method is going to return the value that was originally there, the value that got replaced. Okay, that's going to be a handy trick we want when we want to actually make a list of things we're replacing or removing. Okay, it's an easy way to return it. Okay, not something we're going to use every time. A lot of cases you're not going to use the result of that set method, but it's there for us, and we'll see some examples where we can use it. So next thing we're going to talk about is the get method, and that's going to be how we actually access the elements of our array list. Now with simple Java arrays, we use the square braces notation. Okay, with the array list, we have to use the get method and pass in the index. So kind of similar to what we do with arrays, but not quite the same. All right, so first off, let's declare an array list of double objects called dex, and we'll set it equal to a new array list of doubles. Okay, so after that second line of code, we have an empty array list ready to store double objects. And let's call the add method a few times, which is going to fill this array list with some doubles. So 2.3, a 1.1, a 1.2, and a 6.5. Okay, with that add method, just adding them to the end of the list in order. And we have our indices on these elements, just like we had with simple arrays. And when I call dex.get0, that's just going to return the element at 0, which would be that 2.3. Dex.get1 is going to return the element at 1, the 1.1. Dex.get3 would return the element at index 3, the 6.5. All right, so accessing our elements of the array list, we use our get method. Okay, next up, let's talk about the remove method. And this will be one of the features the array list has for pulling elements out and automatically resizing my array to account for that element missing. So let's make a string array, strs, and set it equal to a new string array that will start out empty. And let's add some stuff to it then. So when I go strs.add a, that's going to put a string A in the first position. When we add B, that'll put a B in the second position. So after my first two lines of code, this is the array I have. And then what the remove method is going to do is you're going to pass in the index of where you want things removed. So we have 0, 1 for our indices. If we call strs.remove 0, that's going to remove what's in that 0th element, and then automatically resize the rest of the array so it would shift the B down to the current 0th element. And if I add C and add D, we can see that remove method work again. So now when I call strs.remove1, it's going to remove what's in the first element, as in the C, and then it's going to shift all the elements above that down 1. So my result would be this array here, BD. Okay, again, that's one of our advantages of the array lists, is they get automatically resized. Okay, it would actually be a pain to make our array objects do this same stuff here. Now our remove method also has a return value, and we'll demo that for you here. Okay, so again, let's create a array list of strings, and we'll add to it an A and a B. And then let's call that remove method and actually print off the result of the remove method. Okay, well, what's that going to print? The remove method returns what gets removed. So as a result of calling this, I'd be left with an array with just the B in it. The A got taken out, and the A gets returned by that remove method. So if I go to print that, okay, the A is going to print off, followed by the actual array when I go to print strs. Okay, why would I want that? Not something that I always use, all right, but if I want to remove something from one array and place it into another, okay, that remove method kind of saves me some steps of setting up temporary variables and using getter methods. I can basically use that remove method to automatically transfer things. We'll see some examples of that as we go through. And then the last method we'll talk about is the size method. Okay, the size method will be used to figure out how many elements are in our array list. Okay, just like we can use length for arrays, we'll use .size for array lists. Now when I run this code here, we're going to create a new integer array list called nums. We'll set it equal to a new array list of integers. And if I called my size method right off the bat here, we get a 0, as in that array list is empty, there's no elements in it. And remember, that's going to be how array lists always start off. Next thing I'm going to do is I'm going to add a 1 to my array list nums. Then if I print the size again, we'd get a 1. If I add the 2 to it and print it again, we get the 2. Okay, so each time I add elements to that array, that size variable automatically gets resized. Okay, my array automatically gets resized, and that's going to happen anytime I add or remove. Okay, that method's going to give me the size. All right, so let's also talk about out of bounds exceptions. Now this is the same kind of issue that we dealt with strings, with arrays, and we'll have the same thing with array lists. So let's say I create my new integer array called array, and let's say I add a 1, 2, and 3 to it. Now let's say I called my add method with an index specified, index of 7. Now this array only goes up to index 2 here. 7's way down the line, that doesn't exist yet. If I called this code here, I'd get a runtime exception. I'd have the same issue if I called the set method on that index 7, or the get method on the index 7, or the remove method on index 7. Okay, we'd get runtime exceptions, index out of bounds exceptions. Okay, so moral of the story is that you can't try to access an element of an array that doesn't exist, that we haven't created yet. You'll get the same index out of bound exception as you would get with strings and arrays. Okay, so now it gets a little more difficult with arrays since they are resizable. Okay, it's easy to write code that makes them bigger or smaller, so an issue you got to pay special attention to with the array lists. And the last thing we'll talk about today is traversing array lists. Okay, it's going to work really the same way as traversing arrays. And this is something we want to be able to do because it's the whole reason we're putting things in arrays rather than storing them as variables. Because it's very easy to loop over them then and make stuff happen with what's stored there. Okay, so pretty straightforward. Let's say I want to print all the elements in an array. Let's say I have a new integer array called array. Let's say we add some elements to it. And then as far as looping over it, what we'll do is just like we did with arrays, we'll have a counter variable starting at 0. We'll run it while that counter variable is less than the size. Okay, so not .length, but .size for the array list. And then as we go through each element, we can say our array.getI to have access to it. And as we do this, this is going to print off the first element, then the second element, then the third element. All right, now just like with arrays, array lists, we can also utilize our enhanced for loop. So once again, let's create an integer array and fill it with some values. And then for that enhanced for loop, what I can do is for each int num in the array list array, so I give it the type we're accessing, a temporary variable, and the list we're getting it from, we can just say system.out.print num, and this will give us the same result. It'll run through one at a time, printing each of those elements. Now we'll be able to use looping to do all the different types of stuff that we did with arrays, such as searching for values, accumulating, finding mins and maxes. Really everything we did with arrays we can also do with array lists. Now there's one part where there's a little bit of a difference with array lists, and that's when you're searching through a list and removing multiple elements. Okay, let's see how that's going to work. We'll have the same type of loop header we just looked at, where we loop from 0 to the array size. And as we're going through, we'll search each element of the array to see if it's equal to some type of value we want to remove. So as an array.getI equals value. And if that's true, what we'll do is we'll just say array.remove I, as in remove the element at index I. But then anytime I'm doing that, I need this extra line of code, I minus minus. Okay, and the reason for that is when I remove something, everything at the higher indices gets shifted down. And if I don't call this I minus minus, if I don't start my index over at that same index I just removed something from, if there's two values I need to remove in a row, we're going to miss that second value. Okay, and that's really the only big difference between looping through and removing elements of an array, where when we remove it, we just remove it from the spot and things aren't resizing, and removing elements from array lists where they get resized. If I do remove something, and there could be multiples of that something, multiple of that element in the array list, I do need to call this I minus minus. I need to count my counter back down one so I can check kind of the new element that's at that index. Again, just a reminder, can't remove elements with a for each loop because we don't have access to the index. All right, so that's the array list class. Okay, that's our next type of data structure we're working with. More powerful, so they will make life easier in some senses, but also with that power comes a little more complexity, so we could say there's a little more to it than our simple Java arrays. Okay, so you're in good shape. Start working on some programs, start cranking out some code. Let us know if you get stuck, and we'll see you folks next time.